Let's look at the solution of number bytes. N is a 5-digit perfect square whose unit digit is the same as the tens digit. How many such n are there? Okay, if we are looking at 5-digit numbers, the range we are looking at is 10,000 to 9999. Square root of 100,000 I know is, 10,000 is 100. Square root of 9999 is slightly more difficult to fathom. Let's see, 99999. If I'm trying to find out square root, making groups of 2, 3, 3, 9, entirely cancelled, 3 added, 6 something, 99, so it will go 300 and 310 something. I will get 61 here, 61 here, I will get 3899. 1 added here, I get 62 something. It should be 626. Let me just be sure. 626. 6 into 6 gives me 6. 3 carried over, 5. And 1 carried over, so 3, 7, 5, 6. So yes, perfectly all right, not a problem. Under root of 5 times 9 is 316.xx. Not really a huge thing, but we can get there. The interesting thing to note is we have to look at perfect square. So unit digit is same as the tens digit. And such numbers, if you want to find, see, either the last 2 digits have to be 0 or the last 2 digits have to be 4, 4. You can go on to check 1, 1, 2, 2, 3, 3, 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. None of these are possible as last 2 digits. With last 2 digits, we have the insight that we know the remainder with 4. And for perfect squares, remainder with 4 can only be 0 or 1. Here you get a remainder of 3. So it is not possible. Anyway, no perfect square can end in 2, and you're getting a remainder of 2. So not possible. Unit digit cannot be 3 for a perfect square. Not possible. Remainder with 4 is 3 here. Not possible. Remainder with 4 is 2 here. Not possible. Unit digit of a perfect square cannot be 7. Not possible. Unit digit of a perfect square cannot be 8. Not possible. Remainder with 4 here is 3. So not possible. So the only 2 cases when the last 2 digits are same and the number is still a perfect square would be 0, 0 and 4, 4. Now, if the perfect square is ending in 0, 0, we know it has to be some multiple of 10 whose square we are looking at. So the list will go somewhere from 100, 110, 120, so on and so forth. The list will keep going up until 310. So how many numbers here? 10 to 31. We get 22 numbers here. Now, the other insight that I want to share, for which this question was created, is this. See, if I want last 2 digits of my perfect square to be 5, 6. If I want last 2 digits of my perfect square to be 5, 6. Although I want 4, 4 here, I will come to it later. If I want the last 2 digits of my perfect square to be 5, 6, do we know of a perfect square whose last 2 digits are 5, 6? Of course, we know 16 square ends with 5, 6. It is 256. So not just 16 square, all numbers which are of the type 50n plus minus 16 will have their square ending in something, something, something 5, 6. How this comes into being is, see, if you were to square this up, you will get 2500n, and therefore the last 2 digits for this portion is 0, 0 plus minus 2 into 50 n into 16. Can you see the last 2 digits is also 0, 0 plus 16 square plus 16 square. So the last 2 digits would only be impacted by last 2 digits of 16 square. And therefore, I can happily say all perfect squares, which are 50n plus minus 16 whole square, are going to end with last 2 digits as 5, 6. Executing the same insight on 4, 4. Do we know of any perfect square that ends in 4, 4? Of course, we know 12. 12 square is 144. So the other list of numbers that I have to check here are 50n plus 12 and 50n minus 12. 50n plus 12 numbers within this range, 100 to 316 will be 112, 162, 212, 262, and 312. And 50n minus 12 would be 138, 188, 238, and 288. So we get 22 numbers which end in 00, and we get 9 numbers which end in 44. So the count of total number of here will be 31, which is the answer. Hopefully this insight is something that you can utilize in future. Next, a 2-digit number is divided by the sum of its digits. What is the maximum possible remainder? Okay, this is also a fairly popular question. Let's see. If I'm looking for the maximum possible remainder, see, remainder will always be smaller than the divisor. So if you're looking for the maximum possible remainder, our best bet would be to find the largest possible, to work with the largest divisors. So if 2-digit numbers are being divided by the sum of its digits, what is the maximum possible sum of digit? It is 18. And this is only true for the number 99. So when I divide this by 18, the remainder that I get is 9. Okay, good enough. Let me check with 17. Sum of digits being 17 is possible if I was working with 98, in which case the remainder I would get would be 13. Or it would also be possible in case of 89, in which case the remainder I get is 4. Clearly, a bigger remainder resides here. I am happy. Now let me check with 16. So here it could be 97, which I divide it by 16, I will get a remainder of 1. But if I divide 79 by 16, I get a remainder of 15. And at this time, I have to stop working, because after this, whatever divisor I take, 15 or 14 or 13, whatever divisor I take, I know the remainder is going to be smaller than the divisor. Can I get a remainder which is greater than 15? Not at all, not possible. So what is the maximum possible remainder? It is 15. For a lot of us, I hope, especially those of us who are reappearing for this paper or who are preparing for the exam, you would already know this question because this is fairly popular. Okay. The number 44 is written as product of 5 distinct integers. If n is the sum of these 5 integers, then what is the sum of all the possible values of n? So first thing I have to do is try and write down 44 as sum of 5 distinct integers. Let's see if we can accomplish that. I know this is 2 into 2 into 11. I've written it in the basest form, but these are not 5 distinct integers. In fact, even if I want to introduce a new number, it would have to be like this. But these are not 5 distinct numbers. If I want 5 distinct numbers, the only way it works is I have to introduce a -1 and a -2 so that the product remains 44 and these integers are distinct. Can I make any more cases? None whatsoever. So what is the sum of all possible values of n? 1 and -1 cancel, 2 and -2 cancel. We're only left with sum of 11. And this is not sum of all possible values of n. This is the only possible value of n. This is the only possible value. This is the only case in which you will get a sum, you will get 5 distinct integers that multiply to give us 44. Okay, next question. Again, reasoning based question. A raised to the power 6 plus b raised to the power 6 is a prime number. If a and b are distinct non-zero integers, then the value of a plus b is. See, if you're lucky and you're able to see it straight away, then wonderful. If you're lucky, you can see, given that this is a theta question, the only possible value that can work is 1 and -1. If you take 1 raised to the power 6 and 1 -1 raised to the power 6, 1 plus 1, you get a prime number 2. Life is sorted if you're lucky. But if you're not lucky, then what processing should have been here? This is as good as some cube plus some cube. So if we break this down, we will get a square plus b square and a raised to the power 4 minus 2a square b square plus b raised to the power 4. This much we'll get. Now we were told that a raised to the power 6 plus b raised to the power 6 is equal to this. We are told this is a prime number, yet we have identified the 2 factors. How will the number on the right remain a prime number only if one of these two constituent factors are one themselves. Can a square plus b square be equal to 1? Of course not, because they are distinct non-zero integers. These are non-zero integers. You cannot have their sum as 1, which would mean this part is equal to 1, which would also mean a raised to the power 6 plus b raised to the power 6 is equal to a square plus b square. Okay, now you can potentially work your way around it. You'll get a raised to the power 4 minus 1 is equal to b square 1 minus b raised to the power 4, which would mean, see, a and b are distinct. A and b are distinct. So of course, a square and b square are not equal. They're also non-zero. So the only way this expression works is if this portion is 0 and this portion is 0, which would mean a raised to the power 4 is equal to 1 and b raised to the power 4 is equal to 1. And because a and b are distinct, the only way it works is if one of them is 1, the other one is minus 1. And then you will reach a result. The value of a and b, or value of a plus b will be 0. The answer can be reached. But if you are lucky, you can directly hit upon this. Given this is a theta question, as soon as you reach one case, that has to be your answer. You don't need to check for more potential cases. Last question. If p, p plus a, and p plus 2a are all prime numbers, and p is greater than 75, then which of the following is a possible value of a? Okay, fun thing. There are two ideas that I want to share here. One, all prime numbers in this world after 2 and 3, that is a valid threshold. After that, all prime numbers can be represented in the form of 6k plus minus 1. 6k plus minus 1. The other idea I want to represent or share with you is, look at this threshold, p being greater than 75. Can you identify and appreciate this is nothing but a distraction to make our work more difficult? Does the behavior of prime number in any form change after 75? None whatsoever. It doesn't change. This is simply a distraction. This is a useless pointer to work with. Even if you were to work with smaller numbers, your answer should be fine. And let us see, among the smaller numbers, among the smaller primes that we are aware of, can we find any case? Let's start working with 5. If I add 8 to it, I get 13. If I add 8 to it, I get 21. So no, 8 is not working. Let me work with 4. If I add 4 to it, I get 9. No, this is not working. Let me work with 6. If I start with 5, I get to 11. I get to 17. Yes, all three of them are prime. Let's work with 7, 5, and 12, and 19. At 12 itself, I know. So this doesn't work. And you can happily mark your answer as C right now. That greater than 75 nonsense you don't have to care for. But in case, no, you are a rule follower and you want to get the answer appropriately, so let's work with generic forms. Prime numbers can either be 6n plus 1, in which case, let us look at, if it was, the common difference was 8. If a was 8, the first number would be 6n plus 1. The next number would be 6n plus 9. And at this time, you can see this number will be a multiple of 3. So not possible. If it was 4, 6n plus 1, and then 6n plus 5, and then 6n plus 9. Again, this would be a multiple of 3. Not possible. With 6, I would have 6n plus 1, 6n plus 1, 6n plus 1. Possible. Not saying that it is definitely the answer, but possible. Then 6n plus 1, checking it 7 now. 6n plus 8. Straight away I can say, okay, this will be an even number. Not possible. So given first option is eliminated, second option is eliminated, fourth option is eliminated, the answer has to be C. In order to do it comprehensively, let us also work with 6n minus 1. 6n minus 1 plus 8 will give me 6n plus 7, and then 6n plus 15. This is a multiple of 3. 6n minus 1 plus 4 will give me 6n plus 3. This is a multiple of 3. 6n minus 1, 6n plus 5, 6n plus 5, nothing changes. Here 6n minus 1 plus 7 would give me 6n. This is a multiple of 6. This is out of contention. Answer has to be 6 only. That will be all for this episode. Hopefully you learned something. Okay, people, bye.